we're going to go on and get started on this here. So let's focus in on these. Now, again, we're finishing up these note sheets today. This will be the last day we're on this note sheet with multiplication. We're going to be starting division tomorrow. And luckily, the difference between multiplication and division is very, very small. It's only 2 steps, if you can call it 2 steps, mainly just 1 step. Difference. Now these here, this one and the next one are going to be some of the hardest ones we look at. And incidentally, there's not specifically one like it on the homework. But it is still good to look at. And the reason I put this on here is not so much to freak you out about these, but to show you that even if we take this to a higher level, it's not that much more. And the biggest thing with these here is, again, calculating and factoring the ones where we can see the factors first, or see them a little bit easier than the others. Because we do have c to the third plus 8, c cubed, perfect cubed, 8's probably a perfect cube, so we do have a sum of 2 cubes. But our c to the 6 minus 4c to the 5th plus 4c to the 4th has the greatest common factor of c to the third is a common factor, but it wouldn't be the greatest common factor. It'd be c to the 4th. Because again, when we have a common variable across all 3, we take whichever one has the smallest exponent. C to the 4th. They all have at least 4 c's in each term. Because if we remove c to the 4th from c to the 6th, we're left with c squared. If we remove c to the 4th from 4c to the 5th, we have minus 4c. And when we remove c to the 4th from 4c to the 4th, we just have 4. Now the other one we do have a greatest common factor is our c to the 5th minus 4c cubed. They both have c. And this one we can factor out c to the 3rd, c cubed. Because if we remove c to the 3rd, or we factor it out of c to the 5th, we're left with c squared. If we factor the c to the 3rd out of 4c to the 3rd, we're left with 4. So it took it from 2 expressions, c to the 6 minus 4c to the 5th plus 4c to the 4th, something that looked like it would be very challenging to try to factor, c to the 4 times c squared minus 4c plus 4. We know how to factor the rest of that. The other one, c to the 5th minus 4c cubed. We factor out that c cubed. We're left with c squared minus 4. C squared minus 4 is the difference of perfect squares, yes? So it gives us 2 things that can factor. We took 1 step and it took it from something that looked over the top to something we've done before. C to the 3rd plus 8. This will factor as a sum of 2 cubes. Different color. Because our cubed root of c to the 3rd is c. And the cubed root of 8 is 2. So it's the sum of 2 cubes. I've mentioned this a few times in that the sum or difference of 2 cubes, we do end up with a quadratic term. We have an x squared, our bigger part, the 5 part. It's not factorable and has no real solutions. So that means that there's going to be a quadratic, kind of like our c squared minus 4c plus 4. Something of that type that's going to come out of it that's not factorable. And what would be really nice is if it worked out to be c squared minus 2c plus 4, because if it is, those 2 will cancel out. We'll simplify down. We don't have to do the other one. So in the meantime, let's leave it there. We don't necessarily have to factor it at this point because we are going to have to do a few more steps in factoring. But we can go on and factor our c cubed plus 8. It's kind of nice because it does follow a pattern. The signs are the same. Opposite always end on a positive note. Our first term is c, and the bigger one we have c squared c to the first, no c term. Other spot's 2, middle's 2 to the first. Last one is 2 squared. It's looking like that bigger set of parentheses is lining up with our denominator. Now in that numerator, we'll have c plus 2. The bigger set of parentheses, our c being squared is just c squared. Our c times 2 is 2c, and 2 squared is 4. So we can see that that numerator, the other part of that sum of 2 cubes, does match up with our denominator. Even if it did factor, if c squared minus 2c plus 4 did factor, if they already match up, no reason to factor it because they're all going to cancel out. Now we need to pick between our c squared minus 4 and c squared minus 4c plus 4. Which one of these do we want to factor first? It doesn't matter. We just got to pick one. So our numerator, c squared minus 4c plus 4. Third term's positive, so the signs are the same and match the sign of the middle term. Negative and negative. Factors of our first term, factors of c squared, c and c. Now we have a few options for 4. 1 and 4, 2 and 2. Which one do we want to try first? 2 and 2. And again, we can check and make sure. C times negative 2 is negative 2c. Negative 2 times c is negative 2c, giving us negative 4c. So that is what we wanted. Now that leaves us with our last one to factor, c squared minus 4. C squared minus 4. Difference of perfect squares. The signs would be opposite because we would have plus and minus. C squared is c and c. 4 would be 2 and 2. Anytime we do have two terms being multiplied together, I'd be looking for difference of perfect, or two terms that are being subtracted and one of them is a variable squared. I'd be looking for difference of perfect squares because there's a good chance it is, and those factor pretty nicely. Questions on this so far? Now this is going to end up getting a set of parentheses when we multiply together. Well, now when we multiply these together, it's always good to put these constant terms up front. So our c to the fourth and c to the third go up front. In the numerator we have c plus 2. And we have c squared minus 2c plus 4. And c minus 2 and c minus 2. In the denominator we have c plus 2, c minus 2, and c squared minus 2c plus 4. Questions on how we got to this point here? Because all we've done up to this point is a whole bunch of factoring, not a whole lot else, and then pushing it all together. Because one of the things we have in common on top and bottom is what? Our c plus 2, yes? What else do we have? C minus 2. C squared minus 2c plus 4. C to the third and c to the fourth are in common, yes? There's different ways we can think about this and write this out. Because one that we can do is what we've been doing. Whenever we divide like bases, we subtract the exponents. So 4 minus 3 is 1. Since it's bigger on top, it stays on top. One way I do this, and especially as I'm writing this out, is I know all 3 of these are going to simplify with the numerator, yes? And it's going to reduce this 4 to what? I'll write over the top of it. I will scribble out the exponent of 4 and write it as 1. If it had been c to the 4th over c squared on bottom's gone. C to the 4th is now c to the 2nd. So I'll mark the 4 out and write it as a 2. As a note to myself to see what I have left. Because at this point we still have c. You still have c minus 2 in the numerator. Denominator is gone. There is still a denominator. It's technically 1. We don't have to write a division of 1 in, so we can leave it as this here. And that's the answer. If the numerator simplifies out completely, we have to write it as 1. Denominator we don't have to write in as 1, but the numerator we do. Right. Because 2 is not the same thing as, well, 2 over 1 is not the same thing as 1 over 2. Questions on this here? Questions on anything we've done so far? So would we say that these here are as bad as we thought these were going to be? Luckily, I'm not going to make us go through another one of these. I do enjoy doing these, especially this type. But this one and the last one did not come from our Algebra 2 textbooks. I actually found them online at I think it was a college website's, one of their worksheets. This is college algebra. But I also put these in and throw these in for the Algebra 2 to show the difference from what we do in here in college algebra is not a huge step. It's not something massively new that you're covering. We're covering about 80%, 80 to 85% of what you're going to do in college algebra. The rest of it's like this here. It's just one step further than what we take. And it's not a big leap. Does that kind of make sense? And again, this is stuff that y'all can do. This is the last thing we're going to look at. Now, this does have a cubic in it, which luckily is not too bad. I think some of the cubics we had on the homework and the test was actually harder than this one here. But our first one, x plus 2 in the numerator is just x plus 2. There is no greatest common factor, and the degree is 1. So that's as simplified as it gets. Now, the denominator is x cubed minus 27. We're going to need to factor it, yes? What's the denominator of our second term over here? 1. If it's not given to us, it's understood to be 1, which means when we multiply these together, the x squared plus 3x plus 9 is going to multiply with our x plus 2, not with our denominator. And it only multiplies with 1, not both. Now our 3. Our x cubed minus 27 is most likely going to be a difference of 2 cubes. We can check that off to the side. Cubed root of x to the 3rd is x, and yes, our cubed root of 27 is 3. Now at this point here, again, we're going to have our signs and do this here for the cube. It dawned on me also, I've been saying through most of this factor, whichever one looks like we can find the factors at first, yes? Our first thought's probably not going for the cubic. It's probably going for the quadratic, the x squared plus 3x plus 9. Now, the way we can check it, again, this is more of a side note, our b squared minus 4ac. And for this here, b is 3. 4 is, or A is 1, and C is positive 9. Root 3 squared minus 4 times 1 times 9. If it gives us a domain error, it means that thing's not factorable. So we're going to have to write it back out. Which means I'm hoping this bigger set of parentheses here will end up simplifying to x squared plus 3x plus 9. Because if it does, those two are gone. So let's fill in our terms here. Difference of two cubes, our signs are the same. Opposite, always end on a positive note. Our quadratics, it's looking good for it because the signs do match. First term would be x. Bigger one's going to be x squared, x to the first. Our other term is 3. The middle one would have 3 to the first, and the last one would be 3 squared. First set of parentheses ends up being just x minus 3. The x squared is, well, just x squared plus x times 3 is 3x, and 3 squared is 9. Questions on how we got to this point here? We good with this here? So we multiply them together. We get to this here, and what's in common on top and bottom? Leaving us with that's it. Voila. We have it set up, and as we saw in the last one, kind of helps us kind of predict a little bit that the x squared minus 2x plus 4 is probably not going to factor. X cubed plus 8, sum of two cubes, or x cubed. Cube root of x cubed is x. Cube root of 8 is 2. Our signs are going to be the same, opposite. Always end on a positive note. First term is going to be x. Then we have the quantity x squared. X to the first. Next term. Our other one's going to be 2. In the middle, we'll have 2 to the first, and the last one will have 2 squared. And when we simplify the middle, 2x plus 4. We do get to this point here, which is following the exact same steps, the exact same pattern of what we just had. Questions on this so far? Now we can write it back out like we did on the last one, huh? Right, we can smush it together, right? Because that's really all we're doing, yes? So really this one's going to gain parentheses, and these two lines are going to become, and then what's going to happen? Those are similar on top and bottom, they will cancel, leaving us with that's it. Questions on this here? Question on any of this so far? Any question on anything we've done so far? We feel comfortable with all these here? Now, the ones on the homework are essentially for these here are the exact same, except this guy, and possibly this one are all going to be factorable. Only difference is that you'll actually factor them out, cross them out, and do the same steps. Unlike these here where we just end up crossing that out, leaving us with x plus 5 over x minus 1. And I know that was a big jump, but I jumped straight to the answer for this one here. And all I was saying is that this here is going to factor. This is going to be one of the factors of it, so that's gone. The only other part for our cubic is x minus 1. That's it. Let's see here. X squared plus it could be something like this here. Because this here is going to be something more similar to what's on the homework. If you want to follow along with this one, you can. Because if we look at this here, technically we still have 2 parentheses, or 2 fractions like the last one. The denominator of one of them is 1. But this time, the other 3 spots are factorable. X squared minus 9 is one of the factors that we kind of like, or should be a little bit nicer. X squared and 9 are perfect squares, yes? So we would have plus and minus. X squared's x and x. 9 is 3 and 3. X plus 3, x minus 3. X squared minus 5x plus 6. Third term's positive, so signs are the same and match the sign of the middle term. Minus and plus. X and x. 1 and 6, 2 and 3. It's actually going to be 1 and 6, because if it's 2 and 3, we're looking at either 2 minus 3 or 3 minus 2, which would give us 1. So here we're looking at 6 minus 5 or 5 minus 6, or 6 minus 1 or 1 minus 6 to give us the 5. Yes, to give us a negative 5. X squared plus 6x plus 9. Signs are the same and match the sign of the middle term. Plus and plus. Yes, only factors of x squared are indeed x and x. And 9 would be 3 and 3. So we'd smush them together. And again, we can write them back out. That's perfectly fine. Or connect lines. Because really that's all we're doing. We're just moving them all together. Yes? X plus 3 and x plus 3 is gone. And that's it. So the denominator stays 3. The numerator is x plus 1, x minus 6. And if you're wondering why I flipped those two, there's no reason. I just started writing x plus 1 first. And that's it. So we can see here, the reason I did this one was to show you that there is no real big difference between the ones we did with cubics and these here. We just had to factor in a few more spots. And it is kind of frustrating that x plus 3 was the only thing that canceled in both terms. I was hoping for another one to cancel, but I realized I should have put negative x instead of negative 5x. But here nor there. Because it could be that only one thing cancels, or it could be everything cancels. So the answer for this here, it would be what's left over. So for simplicity's sake, let's just say that we got x plus 3, x minus 3, 2, x minus 1, x minus 3, x plus 3, x minus 1. So we would combine them. X plus 3, x plus 3, x minus 3, x minus 3, x minus 1, x minus 1. So the only thing left on top is 2. Bottom's 1. So if that's not there, anytime, which is, and it comes down to the fact that we're trying to divide. We're essentially everything divided by itself, yes? Anything divided by itself is 1. The only way we can get to 0 is if the numerator becomes 0. The only way we can get a division, actually it becomes 0, is if the numerator became 0. The only way we can get that is with addition and subtraction. Since we're doing pure multiplication division, there's no way for it to get there. And that's it. That is the end of 731.